Let's dive back in with a fireside chat with two folks that should not need introduction from this crowd. We'll have Greg Brockman, Chairman and CTO at OpenAI, and Adam D'Angelo, CEO of Quora, and also a board member at OpenAI. And they're going to talk about the future of AI from their perspective. So please give a warm welcome to them.
Thank you, everyone. So we have a lot to talk about today. I wanted to just start off, and Greg, why don't you tell us about the history of how you got into AI as a field, and how OpenAI got started?
I think for me, the journey really started right before going to college, and I was trying to figure out how to spend my life working on mathematics. And I had gotten really into chemistry in high school, and had actually started writing this chemistry textbook that I felt had this very mathematical bent to it. And in order to actually get this thing out into the world, I decided to build a website. And so I started to learn how to program, and programming was the thing that really just sucked me in, because in math, the thing I really loved was that you could think hard about a problem, you'd understand it, then you'd write it down in this obscure way we call a program. Whereas we call it proof. And then with programming, you do the same kind of thing, but suddenly anyone can get the benefit of the thing that you just thought about and discovered, and that you can build a program that actually works for people. I just started to read more and more about the history of programming and how we got to this place. And you start reading things like Alan Turing's 1950 paper on the Turing test. And in there, he lays out this idea that, look, if we're going to build machines that can actually go beyond having a human who has to sit and understand this entire domain, an incredibly complex problem, if we want to move beyond that to actually having machines that you can interact with and that can solve problems that humans can't understand on their own, that are outside of the grasp of human cognition, you're going to need to go further. You're going to have a machine that can actually learn. And I was so enamored by this idea, and decided that was what I was going to spend my life on. Now, there's only one problem, which is this was 2008, and nothing worked. And so I actually started out at Harvard. I transferred to MIT. Yes. Made a much better choice. But sadly, I dropped out of MIT. Because I really wanted to build things that had a real world impact, and the best thing I could see to do that was to do a startup. And it was 2015. I'd been building this company called Stripe, which some people might have heard of, for the past 5 years, and built it from 4 to about 250 people. And it felt like there was something special happening in AI. Right? That it felt like every day you go on Hacker News and you see a news story about deep learning does something. And I was like, what even is deep learning? And the more that I dug in, the more that I realized that all of those dreams that I'd had in 2008, all those ideas that had so captivated me were finally starting to work. And I just wanted to help try to push them forward and make sure that they're going to actually benefit everyone.
Great, and so OpenAI has come a really long way since it started. Recently announced $1 billion investment from Microsoft. So the thing a lot of people are wondering is, what is, that's a massive amount of money for a research organization. What is the organization going to do with all of that?
I think it's a really important question, and I think that first of all, some framing. I think it's really interesting that if you look at physics, think about places like CERN or think about like the LHC. That the number of dollars that go into things like that is actually really staggering. It's like $20 billion to build a massive particle accelerator these days. And the thing about AI that's so amazing is that there's actually an ROI there. Right, that we actually build these technologies that very directly can benefit people. So I actually think it's actually really important that we as society step up the investment that we make into AI. And very specifically, what we're going to be doing is that we're going to be building massive supercomputers. That I think one of the biggest findings throughout the history of OpenAI has been that we tried a bunch of different things, and what we found really works is scaling up our systems to unprecedented scale.
So I think, so just to be clear, most of the money is going to go to the computer, not to like paying researcher salaries.
Researcher salaries are expensive, but compute turns out to be a lot more expensive.
Right. So I think that there's a common kind of like critique out there that I think a lot of people in academia might say there's a need for improvements in algorithms, and anything you have, you can scale it up and do better. But it seems like OpenAI is taking this unusual approach to AI research and really focusing on scale. How do you think about the reasons for that?
So I think of what we're doing is, you can look back, we published this graph showing the amount of compute used for landmark AI results, not just from OpenAI, but from the whole field, the best results, the most cutting edge ones, the ones you've all heard of, starting from 2012. And we found this incredibly smooth exponential, which, Moore's law was, by comparison, a measly snail pace of doubling every 18 months. The pace that we see in this field in practice for the past now 7 years is 10x every single year. So that's 5 times faster than Moore's law. And so we look at the wave of progress, and you can say, well, that's just a 2012 thing. Like, how long can that really go for? But if you actually zoom out and look at the entire history of this field, and you look back to the very beginning, there's actually a number of people who have written about this. There's this professor named Moravec who wrote about this stuff in the 90s. That the thing that really is tied with all of the major advances has been scaling up and having more computational power. Recently, this professor, Rich Sutton, who is the inventor of reinforcement learning, wrote a blog post called The Bitter Lesson. And in The Bitter Lesson, he says, look, that the thing that we as a field have really valued and really strived for has been new ideas. It makes sense, right? This is the thing that, think about what Einstein did in physics, right? He sat down super long and thought a lot and came up with a brilliant idea that revolutionized everything. And so every AI researcher wants to do that. But the point this post makes is that what actually has worked has been scaling up further, you need to have a general method that can absorb that scale. But we actually have methods like that. And that the work that's required to make them work at 10x larger scale, at 100x larger scale, at 100,000x larger scale is actually pretty small tweaks to the same basic ideas. And so what we see is that we view ourselves as really riding a wave of progress that's 60 years in the making. And so I think that at the end of the day, we view ourselves as pragmatists. We didn't set out to try to build super large supercomputers when we started the company, but we found that those are the results that actually really move the field forward.
So recently you released this really incredible language model called GPT-2, and I think one of the things that was interesting about it can generate incredible text, in my opinion, but the organization decided to take this approach in releasing it where you didn't share the model. And there was kind of an argument and a claim that the model is dangerous and it might not be good for the world for everyone to have access to this model immediately, which is a real break from previous AI research. So how did you think about that? What was the rationale for that? And how do you think things are going to change going forward?
So I think one thing we kind of realized over the course of OpenAI has been that AI technologies are no longer toys, right? And that I think that we're already in a place where, and we can kind of see it in society, that the impacts of these systems are pretty big, right? That you think about things from just like recent years of AI systems affecting the society, that I think it's become very clear that we need to not just be technologists building technology, but we also need to be thinking about the impacts of these systems. And now I think the question that's always been an open question is, okay, so research, when does that start to become something that you actually have to think about impacts from day one? Or is it enough just to be like, kind of on this cutting edge of science and just turning up dirt and then, kind of letting everyone who's productizing that be the ones who think through the implications? And I think that we're close to that tipping point. GPT-2 was the first time where we said, we don't know whether or not this is something that we have to worry about, right? That you can imagine various use cases of, using, generating fake news at superhuman scale. How big of a deal is that? We already have, you can go hire a farm of humans to a bunch of humans to go and write fake news. Like, if you have an AI that can do that, is that a thing that changes the world in a negative way? And we were genuinely uncertain. Within the company, we had a bunch of debates that people made very good points in various directions. And I think it's actually a pretty good policy that if you're uncertain if something you're about to do is a bad idea, that you have some caution. And so that's what we decided to do, is err on that side. But I think even more importantly, we viewed this as an opportunity, because the norms in this field have been towards total open publication. Even the idea of not releasing something is something that I think for a lot of people is this emotional shock, right? This idea that because it's almost this feeling of like, look, I spend my whole life trying to develop new stuff, And are you telling me that I might be doing something bad? Like, and that's not really the statement that we want to make, right? I think that it's really important to continue to make the progress because there's so much benefit there. But at the same time, we also need to take responsibility for what's coming next. And so what we really wanted to do, the opportunity here, was to change the norms in the field. To have a norm that, yes, you actually can go through a process and think about how to release something in stages or how to kind of bring people in incrementally rather than just blasting it out to the world. And so it generated a huge amount of controversy. I think that people, one thing we learned was that just because there's a very nuanced message that I just said, and it doesn't always come across in headlines, and so people read the headlines and think that's exactly what you said. But the thing that I think is really encouraging to me is it actually worked. We've actually seen a number of organizations replicate our results and also follow the same kind of staged release pattern that we have. And so I think we've gone from a world where the idea of not releasing something was a fundamental violation and insult to science to a world where actually thinking about the implications of your work, taking that seriously, is supported.
Cool. So another big result this year was OpenAI 5. Can you talk a little about what that was and why you think it was important?
Yeah, so we spent about 2 years working on a system to play the very popular video game Dota. And there's a couple of reasons we picked this game. One is that it has a very large player base that are very, very dedicated to being the peak of human performance at this game. To give you a sense of scale, it's like the prize pool is the biggest of any esports game. It's about, I think, $40 million each year goes to these professional esports teams that all live together in these gamer houses to try to maximize their team effort. And it's a 5-person game, so there's coordination and teamwork and strategy, and that's what the game's about, rather than trying to click super fast like other games. And so we actually last year went to the World Championships and played against some pros, and we lost. And this year, what we did is we just trained for longer, and then we beat the world champions. And the reason this is really exciting is twofold. One, we're not a gaming company. That's not what we're about. We're not excited about just building AI agents and games for its own sake. The thing we are excited about is building general purpose technology that we can apply to other problems, right? That what we really want is to increase the generality of the systems we build and apply them to more and more problems in the world. And so we actually could take the training system for this game and applied it to make a robotics breakthrough. We're able to control a robot hand to perform a task that no one else could.
Mm-hmm. So one of the things I wonder, and I've heard other people wondering about, is that in playing a video game like Dota, there's the part of it that's you got to have a good strategy, but there's another part of it that's like how fast you can click is actually a huge advantage. And so, I feel like I could build some system to play Tetris better than any human, and it wouldn't really be impressive because it's just it's all about reaction time. How do you respond to that? What do you think about that critique of the Dota project?
Yeah, so I kind of look at, first of all, the game itself. If you contrast with something like StarCraft, in StarCraft, the pros literally measure their skill. One of their metrics is how fast they can click, the number of actions per minute. In Dota, none of the pros track that because it's not actually that important for the game. A second thing I think is interesting is that when we lost last year against pros, everyone said, aha, this shows that AI is not smart, it can't strategize, it can't solve these important problems that humans do. And then when we won, people then say, oh, well, you could just click faster than people. And so kind of got to make up your mind. But a third thing I think is really fascinating is that the team that we beat, so they were the world champions for the previous year. So this year, just a couple weeks ago in Shanghai, became the world champion again. They became the first team in Dota history to ever win 2 championships, much less in a row. And the way that they were playing was that they were being very aggressive and taking all these fights, and that they were doing these early buybacks for all these in-game things that people used to say, oh, that's the only reason that the AI is winning, is that it's able to do these things that no human would ever do. And so in fact, it turned out that the humans now actually play a lot more like what we saw from our bot. So I actually think that's, at the end of the day, that I think is what we're going for, right? That you want to have systems that can tell humans something they didn't know, and that together that you can actually achieve things that would be impossible otherwise.
Okay, so I want to go on to another topic. So OpenAI has generated a lot of hype and media attention. So through these things like GPT-2 model being too dangerous to release through beating the world champions at Dota. And I think there's a concern from some researchers that if there's too much hype around the potential of AI and the promise of general AI, then that's going to set an impossible standard. And then when the field doesn't reach that, it's going to lead to some kind of like AI winter, like what happened in the past when the things got too hyped up and then the results didn't really deliver on the hype. So how do you think about that? Do you think there's a risk of another AI winter? Do you think that we should be trying to like keep expectations low?
So I think that's a really interesting question. I think there's kind of I have two angles on it. The first angle is to ask, what is different today? And I think one thing that people do wrong, actually, is I think people don't think that hard about the history, right? We all have this picture in our head that we almost have these scars of the past of, just like somehow there was overhype in the past and that, bad things happened and we don't want that to happen again. But if you actually go and read the histories, the story is very interesting. First of all, that one thing that has really changed is the fact that the funding all used to be academic, right? It used to be that, it was like various funding institutions, and really the whole reason deep learning was able to stay alive was that there was this Canadian moonshot organization that was willing to take a crazy bet on these neural net people. And it was really subject to the fashions of academia and kind of what was popular. Whereas today, what drives AI research and what drives the funding is commercial value, right? You have companies like Google, Facebook, you have companies like Microsoft that are investing $1 billion in us. And actually, the day that Microsoft invested $1 billion, their stock price jumped by $10 billion. And I think that's because investors realize that, yeah, you make AI work, it's going to generate huge amounts of value. And so I think there's a flywheel that was never there before. And so in that axis, I actually think that we're much more on show me the results, and the results are what are going to continue to drive excitement and funding. But the flip side is that it is the case that you look at the accelerating funding and the levels that we're talking about, and I think where the investment should go. Again, like we have this one investment, but I actually think that we're still just a fly compared to what the companies like Google are spending on this kind of research. And if we actually can't get results, if we can't actually deliver value, then we actually shouldn't be funding it at accelerating exponential levels. And so I think that it really comes down to, it's really important that we are calibrated and that we're very honest about what we can do and what we can't do. But I think that the thing that the field does wrong is to become very afraid of anyone getting excited about results. Because I think that there is a lot of exciting progress, and the whole point of AI is to benefit people. And so I think the more that we can actually tell that story, make people realize why AI is something they should be excited about that will make their lives better, I think actually the better it's going to be for everyone.
All right, so we have time for one question from the audience. So someone asked if OpenAI is sort of branded and has a mission around openness, how does that fit with not releasing your work?
Yeah, I think this is also a very important question, right? So when we started OpenAI, we had a goal of trying to make sure that general intelligence, the most advanced AI systems we can build, would benefit everyone. Like, that's what we wanted to do. And we had a plan. Our plan was to involve everyone in the development process of this technology, and that felt like a really good way to make sure the benefits go to everyone. I think it works super well for the internet, worked super well for, think about the impact of open source software. It's a really good strategy that has, I think, really transformed the world in that domain. The thing that's really happened is over the past couple of years that we've realized that these technologies, that they have dual use implications, right? That you can use any piece of AI for something great, but that someone else could repurpose it for a negative application. And we get asked all the time, okay, you're going to build a super powerful technology. How are you going to make sure that people don't use it for bad ends? How are you going to make sure it doesn't fall into the hands of malicious actors? And I think that there's really only one answer for that. That whoever is developing this technology, I think, has a responsibility to make sure it's being kept safe and secure. And so, I think that the shift in strategy for us has been to focus not on including everyone in the development process, though I think the more that can happen, the better it is, because you get all these beneficial effects. But to instead focus as our core strategy on ensuring that everyone participates in the benefits. And so you look at our corporate structure, we start as a nonprofit, we changed to a structure we call a capped profit. And some of the details, there, the whole reason that we did this thing is to ensure that we can actually execute on the strategy. So if we succeed, that the benefits aren't locked up in one institution. And so I think that's a lot of how we think about it.
Great. So thank you, everyone, and thanks, Greg.
Thank you.